An experiment to find the composition of air supporting combustion using white phosphorus. Welcome to our class. The procedure involves the following steps. Set up the experiment as shown in the diagram below, whereby you invert a gas jar on a trough containing water. Label the initial volume of air in the gas jar. Insert the phosphorus using a nichrome wire. Let the phosphorus smolder and record the final volume of air in the gas jar. See in the diagram below. In the discussion of the experiment, we say that red and white phosphorus normally smolder in air. Now this is because phosphorus reacts spontaneously with oxygen to form a mixture of oxides. This explains why phosphorus is stored underwater, as it does not react with water. Now the observations from our experiment are as follows. The level of water in the gas jar rose to occupy the space left by the used up oxygen. Now the level of water in the trough dropped. The amount of phosphorus reduced in size. Phosphorus smolders, producing white fumes. The white fumes are due to a reaction of phosphorus with air to form phosphorus 3 oxide and phosphorus 5 oxide. The chemical equations for the reactions involved are phosphorus plus oxygen gas to give us phosphorus 3 oxide. And the chemical equation is as written down there. Also, we have phosphorus reacting with oxygen gas to form phosphorus 5 oxide. The chemical equation is as shown. P4 plus 5 oxygen to give us phosphorus 5 oxide. In calculation of the percentage of air used by smoldering phosphorus, we shall take the initial volume of air in the gas jar minus the final volume of air in the gas jar divided by the initial volume, then multiplied by 100%. Some sample results from a similar experiment were as follows. The initial volume of air in the gas jar was 80 centimeters cubed. The final volume of air in the gas jar was 66 centimeters cubed. Therefore, we shall take the initial volume of air in the gas jar, which was 80 centimeters cubed, minus the final volume of air in the gas jar, which was 66 centimeters cubed, divided by the initial, which is 80, times 100. And this is going to give us 17.5%. Now, since oxygen is the active part of air, and we are saying phosphorus smolders in oxygen, then we expect this percentage to be about 20.9%. But it is not the case. Why? Because there are some errors which are usually incurred during the experiment. Now, sources of errors include wrong reading from apparatus. If the apparatus are not accurately read, then there can be an error which can affect our results. Another error would be phosphorus may not react with all the oxygen in the gas jar. So we do not have a strategy to be able to ensure that all the oxygen in the gas jar is being used. Therefore, the fact that we are not able to know that then it means not all the phosphorus may have been used during the reaction, and that can pose as a source of an error. Now, after the phosphorus oxides are formed, they react with water, forming acidic solution. Therefore, if blue and red litmus paper are dipped into the resulting solution, red litmus paper will remain red, while blue litmus paper will turn red. Therefore, the solution is acidic, and it gives a pH of 2 with the universal indicator, because phosphoric 5 acid is a strong acid. Let us also note that phosphorus is suitable in this experiment because it does not react with water, number 1, and number 2, it smolders in air. Those are the 2 reasons why phosphorus is very suitable in this experiment. Now, something else to note is that the apparatus should be allowed to cool before taking the final reading, because heat causes expansion of gases. So if you take the reading immediately after the smoldering, you may end up with the wrong readings. Therefore, it's important to allow the apparatus to cool so that we can be able to take the correct reading. Thank you for being attentive to my lesson. Please subscribe, share, comment, and like. Thank you.